After World War II, the UK equipped the Canberra medium bomber, which was considered advanced at the time, with moderate range and bomb load, and was used by many countries including the United States. However, this bomber did not enjoy a long heyday, as in the 1950s, anti-aircraft missiles matured and supersonic penetration became a new technological direction. In 1956, the Royal Air Force proposed to replace the Canberra bomber and put forward the GR.339 plan to design and build a high-speed aircraft capable of conducting long-range tactical nuclear strikes and reconnaissance in any weather conditions, at high and low altitudes, and with the ability to take off and land at field airfields. In 1959, the Air Staff publicly announced a new bomber development project, which was named TSR-2. The TSR-2 had a sleek and simple appearance, resembling a supersonic interceptor rather than a supersonic bomber. The main structure was made of aviation aluminum alloy, while some parts were made of aluminum lithium alloy and titanium alloy. The aircraft's wing had a leading-edge sweep of 60 degrees and was a single wing, with a small wingspan and downward bent wingtips for lateral stability. There were no ailerons on the wing, and the rear edge was equipped with blown flaps to increase lift during takeoff and low-speed flight. The wing also housed an integral fuel tank, and due to the need for supersonic flight, it was designed to be thin to reduce drag, but this also reduced the fuel carrying capacity, thereby reducing the aircraft's combat range. A refueling probe could be installed on the left side of the nose to increase the aircraft's combat range. The aircraft used two Rolls-Royce Olympus jet engines, with the air inlets located on the front sides of the fuselage near the wing roots, in a semicircular shape, with movable conical shock diffusers. The engine was an upgraded version of the one used in the Avro Vulcan bomber, equipped with an afterburner, and was expected to produce 146.8 knots of thrust when matured. The horizontal tail was triangular and positioned lower than the main wing, and both the horizontal and vertical tails were fully movable. The rear of the fuselage had four large air brakes to effectively reduce landing distance. The landing gear was a tricycle configuration, with the nose gear consisting of two parallel wheels, and the main gear having two wheels, with a high ground clearance and low-pressure, tubeless tires that allowed for takeoff and landing on makeshift airfields. The aircraft had an internal bomb bay capable of carrying a 2,720 kg payload, which could be conventional or nuclear bombs. There were also four underwing hardpoints capable of carrying an additional 1,800 kg. For nuclear strikes, the original plan was to carry a Redbeard nuclear bomb, but the final design was changed to two E.177 bombs, with an additional two under the wings. In addition to high-explosive bombs and rockets, there were also considerations for carrying television-guided bombs, as well as the option to mount external fuel tanks for in-flight refueling. The cockpit accommodated a pilot and a navigator, with the front windshield deliberately thickened to prevent bird strikes during low-altitude, high-speed flight, and covered with a layer of metal to protect the crew's eyes from the flash of a nuclear explosion. Both crew members had 00 ejection seats, capable of ejection at speeds of up to Mach 2 or altitudes of 17,000 meters, with the navigator's seat being able to eject independently. When the pilot initiated ejection, the navigator would first be ejected to avoid collision. The avionics system was the Achilles heel of the TSR-2, as the development of such a system was costly, and the UK's economic situation at the time was not prosperous. Despite the lack of technical issues, the UK did not have other similar aircraft to share the development costs, which led to strong opposition and eventually led to the purchase of the US automatic pilot system, which significantly exceeded the budget. The front fuselage sides of the TSR-2 were equipped with film cameras for assessing the effects of nuclear bomb explosions and for simple reconnaissance photography. When conducting specialized reconnaissance missions, a side-looking radar system needed to be installed. The prototype underwent extensive flight testing in 1964, during which many electronic systems were not yet installed, but the aircraft performed well, achieving supersonic flight without using the afterburners, and during high-speed flight, accompanying Lightning fighters had to use their afterburners to keep up. It is worth noting that the maximum speed of the Lightning fighter was close to 2.3 Mach. Some issues were also discovered during testing, such as vibrations in the landing gear and insufficient range. The Air Force's expected Mach 2 flight speed was not achieved, possibly due to combat conditions with weapons attached, and the requirements were subsequently slightly lowered, with a combat radius of 1,200 km and a maximum flight speed of 1.75 Mach. Despite the efforts of the design team, the UK eventually abandoned the TSR-2 bomber due to financial constraints. The opposition seized upon the high development and production costs of the aircraft, turning the TSR-2 into a casualty of factional struggles, and the UK subsequently purchased the US F-111 as a replacement for the TSR-2. The empty weight of the TSR-2 bomber was approximately 25,000 kilograms, with a maximum takeoff weight of about 47,000 kilograms, a length of 27 meters, a height of 7.24 meters, a wingspan of 11.33 meters, and a wing area of 65.3 square meters. It had a maximum speed of 2.15 Mach at 40,000 feet, 12,192 meters, and a combat radius of 1,390 kilometers.